we're now going to have a look at different ways that we can show the electron configuration, so kind of shorthand ways or different models for the electron configuration. Okay, so for example, if we have, let's go for magnesium. So magnesium has 12 electrons. Okay, so if I do the electron configuration for magnesium, it's 1s2, 2s2, 2p6, 3s2. Okay, so that's the 12 electrons accounted for there. Sometimes chemists want to be a little bit lazy, and you know, writing all of this out can take a bit of time. So we can do something called the shorthand configuration or the noble gas configuration. Okay, so what we do is we go to the noble gas just before magnesium. So in the periodic table, if I have a look at it, the noble gas just before magnesium is neon. Okay, so neon has 10 electrons. So the electron configuration for neon is 1s2, 2s2, 2p6. Okay, so to show my shorthand configuration for magnesium, I can, in square brackets, put neon, or the symbol for neon. Okay, and that means that all of this is symbolized over here. Okay, so the electron configuration for neon plus, so this is the electron configuration for neon, plus 3s2. So this is the shorthand configuration that we can use by using the noble gas configuration. Okay, so for magnesium, rather than writing all of that out, you can just write neon and then 3s2. Okay, but if in an exam they ask you for the electron configuration, make sure you write the whole electron configuration. Only if they ask you for the shorthand configuration should you do this. I'll do another example of that. So for example, let's have a look at, let's go for phosphorus. So phosphorus has 15 electrons. Okay, so if I were to do the whole configuration for this, it'd be 1s2, 2s2, 2p6, 3s2, and then 3p3. Okay, so that's my 15 electrons there. The noble gas just before phosphorus again was neon. So neon is 1s2, 3s2, 1s2, 2s2, 2p6. So I can write phosphorus as neon and then just 3s2, 3p3, like that. Okay, so that's the shorthand configuration or the noble gas configuration that we can use. The other thing I want to refer to is a model that we can use to show electrons, and that model is called electrons in boxes. So electrons in boxes. So this is a type of model that we can use to show electrons. So if we start off with hydrogen, okay, so hydrogen is just 1s1. We can show for each orbital, we can draw a box. So a 1s orbital is just going to be one box because s is just one orbital. Okay, so this, I can label that as my 1s. And then I can show my electron in there. Now to show electrons in these boxes, we use arrows. Okay, so given that I've got one electron, I'm just going to use one arrow. Now, remember what I said, so electrons can have a property called a spin up or a spin down. So they can either be an upwards facing arrow or a downwards facing arrow. You can also draw it as like this half-headed arrow here, that's what I tend to do, or that sort of arrow going downwards, so that just means up spin, that means down spin. Either is fine, you can draw it however you want. But bearing in mind, within one box, the electrons must have opposite spins, like that. Okay, you cannot have two electrons with the same spin within one box. Okay, you can't have that. So I can show a hydrogen atom using the electrons in boxes model, like that. If I then go to the next one, which is helium, which is 1s2, I can then again draw those two electrons. They're going to be within one orbital. One's got to be up, one's got to be down, like that. Okay. If we then go to lithium, okay, so lithium is going to be 1s1 and then 1s2. So draw those in, and then it's going to be 2s1, like that. Okay. Let's go to another element and do the electrons in boxes model for that. So if we go to oxygen, so oxygen has 8 electrons. Okay, so if I do the 1s over here, so 2 electrons there, I then move to my 2s. So again, my 2 electrons there, I've accounted for 4 electrons now. Within the second shell, we also now have 2p. And remember, 2p consists of 3 orbitals. Okay, so p does have 3, so I'm going to draw 3 boxes now joined together. Okay, I've now got to put in 4 electrons. Now, in this case, it was fine because you don't move on to the next one until you filled that. Over here, to fill the p orbitals, given that I've got 4 electrons to put in, I put 1 in each first. Okay, so you've got to put 1 in each first. And then once I've filled each with 1, I then go back and start filling with the other spin. Okay, the reason for this is that 2 electrons, even when they're opposite spins, they do repel a lot. Okay, so they do have a lot of electron repulsion. So ideally, if we can, given that all of these orbitals are the same energy level, we can fill whichever ones we want. So electrons prefer it if they're not paired up. So that's why we start filling. So we start filling each of these first, so they're not paired up at the moment. Only when they are full, we then move to pairing them up like that. Okay, so this is the electron in boxes model for oxygen. If we now go to, let's go to neon. So neon has 10 electrons. So again, 1s2, opposite spins, 2s2, opposite spins. When I now go to my 2p, so I've still got 6 electrons to account for, so I fill them up one by one first, and then once each has 1 electron in it, I then pair it out that way. Okay, so that's the electron in a box model for neon over there.